Hello, everyone, and welcome. I'm excited to have you here today for Wastewater Certification Exam Review Part 2. Today's presentation is a comprehensive study guide designed to help you prepare for your certification exams. We'll be covering essential topics like equipment maintenance, safety protocols, pump operations, and collection system management. My goal is to provide you with clear, detailed answers to ensure you're thoroughly prepared. Let's get started. Let's talk about equipment connections and safety. When you're working with chlorine or sulfur dioxide cylinders, it's crucial to always use lead washers. These washers are essential because they provide a proper seal and are resistant to the chemicals involved, which helps ensure safe operation and prevents dangerous leaks. Safety is always our top priority, especially when handling hazardous gases. Next, let's discuss chain of custody. This refers to the documentation that tracks who has had possession of a sample at all times. Maintaining a clear chain of custody is vital because it proves responsibility and helps preserve the integrity of the sample. It's especially important if the results need to be used in legal or regulatory contexts, as it ensures the findings are defensible and trustworthy. Finally, I want to address motor bearing lubrication. For sealed ball bearings in electrical motors, never attempt to lubricate them yourself. These bearings come sealed from the factory and are designed to operate without additional lubrication throughout their lifespan. Adding grease can actually damage the seal and lead to contamination, which could cause motor failure. Proper understanding of these points helps us maintain equipment safety and reliability across all operations. Let's take a closer look at level indicators and valve selection. When it comes to bubbler tube maintenance, the key is to ensure that the air tube stays clear and unobstructed. This is essential because the accuracy of your level measurements depends on it. Regularly inspecting the tube helps prevent blockages caused by debris or mineral deposits, which could otherwise lead to false readings. Remember to check the air pressure settings and verify that the tube connections are secure. If needed, clean the tube to maintain precise and reliable measurements. Moving on to throttling applications, the globe valve stands out as the most suitable choice. Its design allows for fine, gradual control over flow rates, making it perfect for regulating flow rather than just turning things on and off. This is different from other valves like ball valves, which are great for quick shutoff, or check valves that prevent backflow. Gate valves provide full flow or shutoff options, but the globe valve offers that precise flow regulation that we often need in process control. Connecting these points to the overall theme, selecting the right valve and maintaining your level indicators properly ensures accurate control and reliable operation in your system. Let's start by looking at pump couplings and cavitation. Flexible couplings play a crucial role here. They connect the motor and pump shafts, allowing for efficient power transfer. What's great about them is that they can accommodate minor misalignments between the shafts, which helps prevent unnecessary wear and tear on the equipment. This flexibility not only protects the motor and pump, but also ensures smooth operation over time. Now, moving on to cavitation. This is a common issue in pumps, and understanding its causes is important. Cavitation happens when the pump is pushed beyond its design flow rates, basically, when the flow is too high. When this occurs, the pressure inside the pump drops below the vapor pressure of the fluid, leading to the formation of vapor bubbles. These bubbles collapse violently, which can cause serious damage to the impeller surfaces and significantly reduce the pump's efficiency. So, how do we prevent cavitation? The key is to operate the pumps within their specified parameters. Make sure there's enough suction head to maintain proper pressure, and monitor system pressure closely. Regularly checking pump performance indicators can help us catch any early signs of cavitation before it causes extensive damage. Keeping these factors in mind ensures the longevity and reliable performance of our pumping systems, tying back to our overall goal of efficient and durable operation. Let's take a closer look at the different types of pumps and their applications. First, we have positive displacement pumps. These are pretty interesting because they work by trapping a fixed amount of fluid and then forcing it through the discharge. This means they provide a very consistent flow, no matter how the pressure varies, which is crucial in many wastewater scenarios. Next up are centrifugal pumps. These are probably the most common type you'll encounter in wastewater treatment. They operate by using rotational energy, essentially spinning to move fluids. One of their key advantages is that they can handle solids quite well, and they're relatively simple to maintain, making them a reliable choice for many applications. Then we have turbine pumps, which are especially suited for deep well applications. They are designed to operate efficiently at high pressures and feature very close-fitting impellers. However, because of their precision components, they tend to require a bit more maintenance, so that's something to keep in mind. Understanding these classifications, positive displacement, centrifugal, and turbine, really helps operators choose the right pump for each specific application. It also allows us to anticipate maintenance needs more effectively. Remember, each type has its unique strengths and is suited to different parts of wastewater systems, playing a vital role in overall system efficiency. Now, let's take a closer look at altitude valves and pump diagnostics. The main purpose of an altitude valve on an elevated tank is to control the maximum filling level in our distribution storage. It automatically closes once the tank reaches its designed maximum level, which is crucial for preventing overflow and maintaining the proper system pressure. This helps ensure our system runs smoothly and safely. Next, let's talk about the pinging sound you might hear from a pump. The most common cause of this noise is cavitation. When cavitation occurs, vapor bubbles form and then collapse inside the pump, creating that distinctive pinging sound. This is a clear sign that something isn't right, and it requires immediate attention. If left unchecked, cavitation can cause damage to the impeller and shorten the pump's lifespan. To diagnose cavitation, you should first check the suction pressure and flow rates. Make sure the pump is operating within its designed parameters. It's also important to inspect for any air leaks in the suction piping, as these can contribute to cavitation. Lastly, verify that there is sufficient NPSH, net positive suction head, available to prevent vapor formation. Finally, let's briefly look at pump categories. There are three main types used in wastewater operations: centrifugal pumps, positive displacement pumps, and turbines. Each type has its specific applications and advantages, but understanding these categories helps us select the right pump for each situation and troubleshoot effectively. Connecting all these points back to our overall theme, maintaining proper operation of altitude valves and pumps is essential for system efficiency, safety, and longevity. By understanding these components and their diagnostics, we ensure our wastewater systems run reliably and effectively. Let's take a closer look at the ventilation and check valve requirements for the wet well. First, the wet well ventilation. It's essential to have a mechanical system in place that can exchange the air at least 12 times per hour. This frequent air exchange helps to remove hazardous gases like hydrogen sulfide and methane, which are common in lift station environments. Maintaining proper ventilation is crucial for ensuring safe working conditions for everyone involved. Next, let's discuss check valves. These are the one-way valves that prevent water from flowing backwards in the system. They automatically close if the flow reverses, which is vital for protecting the pumps from backflow. Additionally, check valves help prevent the system from draining when the pumps are shut off, maintaining system integrity and preventing potential damage. Finally, I want to touch on vortexing conditions. Vortexing can occur if the wet well level gets too low or if the pump flow rate is too high. When this happens, a swirling action, or vortex, forms and draws air into the pump intake. This not only reduces the pump's efficiency, but can also cause damage through cavitation. Understanding these points helps us ensure the lift station operates safely and efficiently, supporting the overall reliability of our wastewater management system. When we throttle the discharge valve on a centrifugal pump, it causes a few key changes in how the pump operates. First, you'll notice an increase in the head pressure, which is basically the resistance or pressure the pump has to work against. As the valve closes, resistance builds up and the pressure at the pump's outlet rises. At the same time, because the flow faces more resistance, the overall flow rate, or how many gallons per minute are being pumped, decreases. This is important because it shows how restricting flow impacts system performance. And finally, as the flow drops, the motor doesn't have to work as hard, so the electrical current it draws also decreases. This relationship between throttling, pressure, flow, and amperage is fundamental to understanding how pump performance curves work and how we control and optimize system operation. Moving on, let's look at the Wayne sewer ball design. The ribs on the outside of these sewer balls are specifically designed to create jet action. This turbulence helps to flush out the sewer line more effectively during maintenance, improving cleaning by ensuring water flows around the ball and agitates any debris or buildup. And lastly, I want to highlight the backwater valve. This device is crucial because it prevents wastewater from flowing back into the building during overload conditions, like system surcharges or overflows. It acts as a barrier to protect the interior of the building from sewage backup, maintaining hygiene and safety. All these components and controls work together to ensure efficient, safe, and reliable sewer and pump system operations. Let's start by looking at odor control and pump classifications. When it comes to sewer odor control, chlorine is often used because it effectively oxidizes hydrogen sulfide and other compounds that cause odors. However, it's important to apply chlorine carefully, as improper use can create hazardous conditions or even damage the infrastructure of the collection system. Moving on to pumps, reciprocating pumps, also known as piston pumps, are a key type used in these systems. They operate by using a piston or plunger to move fluid through chambers. What's important about these pumps is that they provide a very consistent flow, regardless of changes in discharge pressure, making them reliable for various applications. Now let's discuss confined space identification. An operator control room is not considered a confined space, which is good news for safety. Confined spaces are characterized by limited entry and exit points, poor natural ventilation, and are not meant for continuous occupancy. Examples include manholes, anaerobic digesters, and lift station wet wells. These spaces require special entry procedures to ensure safety. So recognizing and understanding these distinctions is crucial for safe operations. All of these points tie back to our overall goal of ensuring effective, safe, and efficient management of sewer systems. Now, let's talk about lockout and tagout safety protocols. A key part of this is the warning tag requirements. When a switch is locked out, the tag needs to include specific information to ensure safety. First, it must have the name of the person who performed the lockout, so everyone knows who is responsible. It should also state who is authorized to remove the tag, which helps prevent accidental re-energizing of equipment. Additionally, the tag must include the date and time of the lockout, the reason for locking out, contact information for the responsible person, and an expected completion time. All this information helps maintain clear communication and safety during maintenance. Moving on, let's consider some hazards related to certain materials. Gasoline and volatile solvents are particularly problematic in sewer systems because they can vaporize and create explosive atmospheres. These vapors pose a serious risk to workers and can damage infrastructure, so they must be handled with extreme caution and avoided in these environments. Finally, I want to highlight high-efficiency pumps, specifically vertical turbine pumps. These pumps are known for their impressive efficiency, often between 80 and 95%, especially at high pressures. They feature impellers that fit very close to the casing, which enhances performance, but also means they require careful maintenance. While they do have higher maintenance costs, their ability to operate effectively in deep well applications makes them invaluable in our industry. Understanding these key components helps us ensure safe and effective operations. Let's start by talking about the primary purpose of well grouting. Essentially, its main goal is to prevent surface water from contaminating the water that's being drawn into the well. Grouting fills the space between the well casing and the borehole wall, creating a solid barrier. This barrier is crucial because it stops surface pollutants from seeping into the aquifer and compromising water quality. Next, we have the static water level. This is simply the water level in a well when it's not being pumped. Think of it as the natural, undisturbed height of the groundwater. It's an important measurement because it provides a baseline for understanding how the aquifer behaves and helps us evaluate well performance over time. Finally, let's look at pressure control valves. A common type used is the globe valve. These valves are especially useful because they allow for precise control of pressure within the system. By adjusting the valve, operators can fine-tune the flow rate, gradually throttling the pressure up or down as needed. This control is vital for maintaining system stability and protecting equipment. Connecting all these points, understanding how to properly seal a well, measure its natural water levels, and control system pressure are all key to effective well management and ensuring safe, reliable water supply. Let's talk about screen maintenance and chlorine safety. First, when you're working inside the screen housing to fix a plugged spray nozzle, it's crucial to turn off, lock out, and tag the motor control. This step is the only safe way to prevent accidental energization of the equipment while you're working on it. Remember, safety is always the top priority. A critical safety rule to keep in mind is never to rely solely on local switches. Always follow the full lockout/tagout procedures, which include physically locking the controls and placing warning tags. This way, you and your coworkers stay protected from unexpected energization. Now, moving on to chlorine leak response. If there's a leak of gas chlorine, using water is a key part of managing the situation. When water reacts with chlorine gas, it forms sodium hypochlorite, which can actually be salvaged for future use. This reaction produces hypochlorous acid and hydrochloric acid, which can then be neutralized and recovered as a bleach solution. In case of a leak, the first step is to apply a water spray to contain it. Always evacuate the area immediately to ensure everyone's safety. Wear the appropriate personal protective equipment, or PPE, to protect yourself from exposure. And finally, contact the emergency response team right away. These steps are vital in ensuring safety and minimizing environmental impact during chlorine leaks, tying back into the overall theme of safe and responsible plant operation. Let's take a closer look at pump troubleshooting and motor types, starting with low amperage diagnosis. When you notice that a centrifugal pump is drawing less current than usual, one possible cause could be a broken force main. Imagine the discharge line breaks, resistance drops significantly, which allows the pump to spin more freely and with less load. As a result, the current draw decreases. Now, on the flip side, if you see an increase in amperage, that could indicate a different issue. For example, a clogged pump causes the motor to work harder against the obstruction, which ramps up the current. Similarly, a closed discharge valve creates resistance, making the pump work harder and increasing amperage. If the impeller is wrapped or fouled, that added friction and resistance also lead to higher current draw. Moving on to motor types, squirrel cage motors are very common in wastewater applications. They're simple and robust, with rotors that don't require windings. The key advantage here is their low starting torque and reliability, which means less maintenance and fewer failures over time. Finally, let's talk about the loss of prime. This often happens after starting the pump and can be caused by suction issues. Air leaks in the suction piping, inadequate submergence, or vortexing can all introduce air into the pump. When air enters, it breaks the prime, which stops the flow and can cause the pump to lose its prime entirely. Recognizing these signs helps us diagnose and fix problems efficiently. Let's start with the instituform process. This is a trenchless method of sewer line rehabilitation that involves inserting a polyester fiber felt tube into the existing pipe. One side of this felt tube is lined with polyurethane and impregnated with a liquid thermal setting resin. When installed, it creates a new, durable pipe inside the old one without the need for excavation. This technique is highly effective because it restores the pipe's structural integrity while minimizing disruption. Next, let's talk about the purpose of the camera skid. It's essential to use proper skids on the TV camera during inspections. The main goal is to keep the lens centered within the pipe. Why is this important? Well, centering ensures that the images captured are consistent and clear throughout the inspection process. It helps us get an accurate assessment of the pipe's condition and identify any defects properly. Finally, on picture quality, pulling the camera from downstream to upstream is the best practice. Doing so allows the camera to move smoothly with the help of gravity, reducing the chances of it getting stuck or losing focus. This direction also gives us better control during the inspection, ensuring we gather reliable and high-quality visuals of the pipe's interior. All these points, from the instituform process to camera handling, are interconnected. They work together to ensure effective, efficient, and accurate sewer rehabilitation and inspection, which is what we aim for in our overall project. Now, let's talk about some immediate health threats. Benzene and mercury are particularly dangerous because they can cause serious health issues very quickly if we exceed safety standards. These substances are highly toxic, and even at low levels, they can have severe effects on our health. That's why it's critical to take immediate action whenever we detect them above regulatory limits. Next, I want to touch on electrical resistance, which is measured in ohms. This tells us how much a material opposes the flow of electric current. Understanding electrical resistance is essential, especially when troubleshooting motor and control system problems in wastewater facilities. Connecting these points, recognizing the relationship between electrical measurements and potential hazards, helps us diagnose issues more accurately and operate electrical systems safely. Overall, whether it's managing hazardous substances or electrical systems, staying alert to these fundamentals is key to maintaining a safe and effective wastewater treatment environment. Let's take a closer look at pump performance and head calculations. First, when we talk about the impact of speed on flow, if we increase the pump speed while keeping the head constant, you'll notice that the gallons per minute output will go up. This is because of the affinity laws for centrifugal pumps, which tell us that flow is directly proportional to the pump's speed. So, increasing speed directly increases flow rate, which is a key point to remember when adjusting pump operation. Now, moving on to the difference between dynamic head and static head. The main difference here is friction head. Dynamic head includes all the losses caused by friction in pipes, fittings, and valves, so it accounts for energy lost as fluid moves through the system. Static head, on the other hand, only considers elevation differences and pressure requirements. It doesn't change with flow rate. Let's break down static head first. It's basically the elevation difference plus the pressure head, and importantly, it remains constant regardless of how much fluid is flowing. Whether the pump is just starting up or running at full speed, static head stays the same. Friction head is all about the energy lost due to pipe friction. As flow increases, so does the friction head. More flow means more resistance, which leads to greater energy losses. Finally, dynamic head is the total head, which combines static head and friction head. Since friction head varies with flow rate, dynamic head also varies. Understanding these differences helps us optimize pump systems, ensuring they operate efficiently and reliably within the system's requirements. Now, let's take a closer look at butterfly valves and manhole functions. One thing to keep in mind with butterfly valves in wastewater lift stations is that they have a tendency to accumulate debris. Even when the valve is fully open, the disc stays in the flow path, which can create spots where rags, grease, and other materials tend to collect. This buildup can sometimes interfere with the proper operation of the valve, so it's an important consideration in maintenance and design. Moving on to manholes, their main purpose is to provide access points for maintenance, inspection, and cleaning. They also play a crucial role in changing the flow direction of the system, helping the collection system navigate around obstacles and follow the street layout efficiently. You'll typically find manholes at pipe intersections, where the flow changes direction, or at points where the pipe grade or size changes. They're essential for ensuring the system remains accessible and functional over time. Lastly, let's talk about chemical protection. When dealing with hazardous liquids like toxic acids or bases, it's vital to have proper personal protective equipment. The best defense against skin contact is wearing boots and gloves specifically designed to resist chemicals. Using this specialized equipment forms the first line of defense, helping keep workers safe from exposure to dangerous substances. Putting all this together, understanding these components and protections ensures the wastewater system operates smoothly, safely, and effectively. Let's take a closer look at oxygen levels and pump performance. Normal oxygen levels at sea level are about 19.5%, which is considered typical atmospheric oxygen. However, it's crucial to be aware of the safe and dangerous thresholds. For instance, when oxygen drops to around 10%, it becomes immediately fatal to workers. That's why maintaining safe oxygen levels, generally between 15 and 20%, is essential for safe confined space entry. Remember, if the oxygen content falls below 10%, it can be deadly. Monitoring the atmosphere continuously and testing before entry are vital safety measures, since oxygen deficiency is a leading cause of confined space fatalities. Now, shifting gears a bit, let's consider what happens as the wet well rises. When the wet well level increases, the net positive suction head available, or NP-SHA, also increases. This is beneficial because higher liquid levels exert more pressure at the pump's suction side. As a result, pump performance improves and the risk of cavitation, those damaging bubbles forming inside the pump, is significantly reduced. Finally, I want to touch on pneumatic ejectors. These are specialized systems used in wastewater lift stations. They work by pressurizing a receiving chamber, which causes an inward check valve to close and an outward check valve to open. This process uses compressed air to lift and move wastewater without relying on traditional mechanical pumps. It's a clever way to handle wastewater efficiently, especially in confined or challenging environments. Let's take a look at the components and issues that can arise in a collection system. First, the inverted siphon. Despite what the name suggests, it's not a true siphon. Instead, it's a pressure pipeline used to carry wastewater under depressions like creeks. These operate under pressure, which allows sewage to cross beneath obstacles efficiently. Next, we have inflow symptoms. When we see muddy water or notice increased flow during rainfall, that's often a sign of inflow. This happens when surface water, like from roof drains or catch basins, directly enters the collection system. During storms, this causes rapid increases in flow, which can strain the system. Moving on, volatile solvents present a significant hazard. These substances vaporize easily, creating potentially explosive atmospheres within the system. If there's a spark or static electricity, it can ignite these vapors, leading to dangerous explosions. Finally, let's talk about the vacuum system profile. Typically, it has a sawtooth shape or undulating profile. This design allows the vacuum sewer to follow the terrain, with collection points at low spots and lift points at higher elevations. This profile helps maintain proper system operation across varying ground levels. Understanding these components and issues helps us manage the collection system more effectively and ensures its safe, reliable operation. Let's take a closer look at some key safety protocols and system characteristics to keep in mind. First, hydrogen sulfide, or H2S, smells like rotten eggs. This distinctive odor is actually detectable at very low concentrations, which is helpful as an early warning. However, the danger is that at higher concentrations, H2S can deaden our sense of smell, making it extremely hazardous because we might not realize we're exposed. Next, if you encounter a coworker who has just passed out, your first step is to check their breathing and heartbeat. This quick assessment helps determine the right emergency response, whether you need to start CPR or if they are breathing but need other assistance. Now, moving on to electrical safety. Death from electrical shock can happen even with as little as 33 milliamps of current. That small amount can cause ventricular fibrillation, which is a deadly heart rhythm. This underscores why strict electrical safety protocols are absolutely critical in wastewater facilities. Let's also talk about pathogens. These are bacteria, viruses, or cysts that can cause disease, and wastewater often contains numerous pathogens. That's why proper hygiene, vaccination, and safety procedures are so important for protecting ourselves from infection. Another point is oxygen deficiency. For example, a manhole with an oxygen level of 17% is considered oxygen deficient. Safe entry requires oxygen levels between 19.5 and 23.5%. At 17%, workers face increased breathing rates, impaired judgment, and potential health risks, so monitoring oxygen levels is vital before entering confined spaces. Finally, the outfall sewer is the line that carries treated effluent from the wastewater treatment plant to its discharge point in a receiving water body. Understanding how these systems work helps us appreciate the importance of proper operation and safety. Overall, understanding these safety protocols and system characteristics is essential. They protect us, our coworkers, and ensure the effective operation of wastewater systems. Always remember, safety should always come first. Never compromise safety for convenience or speed.